Alright, we're still working on the model problem on page 518, and what I was going to do was type in all of our data points, our X data points into list 1 and our Y data points into list 2. And our X data points are going to be the length of the right foot. Okay, so we have 25.4 from the book. Let's see, 25.4, 26.4. And while I'm doing this, John, I just want to emphasize the point that a lot of the importance of taking this test is going to be based on lists and data points. So you really need to be careful when you're typing these in or when you're writing them into your calculator, because if you get them wrong, then obviously your equation is going to be wrong. And then in the Y or the L2, I'm going to do the height. 165.1. So a lot of the things that are important on this test are you really need to just be careful when you're putting things into your calculator. But for the most part in this unit, the calculator does all of the work for you. Okay, so I put all my data points in, and then we're in the middle of creating a scatter plot. And we already turned that plot on. So if I go over to, I'm going to do zoom stat, because that will set it up perfectly for my scatter plot. And that's option number 9, zoom stat. And then look at, there you go. We graphed it for us, and that's our scatter plot. And that represents all of the points that we just plugged in. So part A said create the scatter plot that models this data. There we go. Beautiful scatter plot. Part B. To the nearest hundredth, determine the linear regression equation for the given data. Now this is not something that you have done before, so this is really important. Let me explain this to you. Those are our data points, and then I want to know what the equation is of the line of best fit that will go right through that. So obviously we're still in the stats chapter. So I'm going to hit the stats button again because that seems to be where everything is. I'm going to go over to calc again because that's where everything is again. We're not hitting one variable stats this time. I don't want to know what the mean, the median, and the mode is. This time, if you take a look below here, I see linear regression, quadratic regression, cubic regression, quartic regression. And I'm going to talk to you about all that stuff. But this says, the question said, determine the linear regression equation. And the best part about these kind of problems is that the textbook or the test will tell you, hey, go find the linear regression equation, or go find the quadratic regression equation. And all you have to do is you have to pick the right one. So I'm going to come down here to option number 4 and hit enter. Linear regression. Now you need to tell your calculator where the information is that we're looking for. Okay, remember we put all of our values in list 1 and list 2. So just like if we were trying to find the mean, the median, and the mode, we need to tell the calculator where our information is. L1 with a comma in between, L1 comma L2, and hit enter. There we go. And it looks kind of weird if you've never seen it before, but you already know that the equation of a line is y is equal to, we normally call it mx plus b, but the calculator is calling it ax plus b. So that's how a typical linear equation would look. So it's saying, it gives you right at the top line, that top line right there tells you exactly what your equation should look like when you write it out. Okay, so y is equal to ax plus b. And then it says, here is my value for a, and here is my value for b. All you need to do is write in the numbers. And unfortunately, because the majority of the work that we just did was typing numbers into our calculator, if you want to get full credit, and I'm telling you this now, if you want to get full credit for this test, you need to write out a lot of decimals first and then round, because this is the only way that we can see that you got the right answer in your calculator. Okay? So that was my A, X, plus B, and my B is right here. It's 43.5. 4.82205, and there's more too, but I ran out of room. Okay, so the question in your workbook says, find it to the nearest hundredth. That means that I can just take these values and round to the nearest hundredth. This is tens, then hundreds. So all you have to write 4.83x plus 43.82. Isn't that kind of cool? It gave you exactly that line, that equation that gives you exactly the line of best fit. And then number C in our book, it says, what is the correlation coefficient rounded to the nearest hundredth for the size of the right foot versus the height? Correlation coefficient, that was what we just talked about over here. Correlation coefficient is an R. That's just the letter that we use to represent it. And the correlation coefficient in this question is given to you as well. Now, the reason why the correlation coefficient was given to you, John, was because we turned the diagnostic on. Do you remember me doing that? I went down here to the catalog and I turned the diagnostic on. And if the diagnostic was not turned on, you would not see those last two lines with the R values. Okay? So because I turned the diagnostic on, that's why the R values or the coefficient correlation is given to me. I really don't know what R squared is used for. I think that's for higher level stats. All we need to know is the R, that lower, the last line right there. So our R is 9.775545116. And it wanted the correlation coefficient rounded to the nearest tenth. No, hundredth. So 0.98. Now, I want to know what you think about that correlation coefficient. I want you to think about what I just taught you about correlation coefficient. This R value is a 0.98. And remember how I said that correlation coefficient, number one, it lies between -1 and a +1. And 0 is right in the middle. So 0.98 is about right here, probably even closer. 0.98 is right there. And what happens as we get closer and closer to a +1? It's getting closer and closer to a perfect correlation, meaning that when we looked at that scatter plot, those points are, they're not exactly perfectly on the line. Like those two are a little bit off. That one might be a tiny bit off, but the rest of them look like they're pretty much right in a straight line. So those 2 points right there are pretty much screwing up our perfect correlation. But 0.98 is a very, very, very strong correlation, which means that these points they lie pretty much almost exactly in a straight line, okay? So when you're answering questions like this, don't only answer the question and say, oh, 0.98. Think about what that means. It means that these points have a very strong correlation and they're almost perfect. Okay? Interpolation and extrapolation, that just means that we can use linear regression. We can use that equation that we just wrote right here to figure out. Interpolation is finding values within the range of the original data. So for example, this was based on foot size and height or something like that. And we only have these couple of points, but if I wanted to know, the point right there, what would happen if a guy was exactly this tall? What would his shoe size be? I can use the equation that I just wrote. I'm missing an equal sign. I can use that equation. I can fill in a value for x and solve for y and get my answer out. That's what we mean by interpolation, is finding like missing values that are within the range of the original data. Extrapolation is using that equation to predict data values. So once I have that equation, I could plug in whatever x value I really wanted to, and it might be some huge x value that's not even on this chart. It might be all the way out here somewhere. But I can use it to extrapolate and kind of like predict, well, I don't have a data point that tells me what would happen out here, but I could use this equation to kind of predict what would happen. And you will have a question like that on your test, and I'm going to hopefully do my best to prepare you for that. So let's see, this is homework. I think it's 110. Let's see. You know what? I don't think that page 517 to 518, 1 through 10. 517 through 18, 1 through 10. And then I don't think she had you do these questions. So this is homework 110. So just that part. Alright, and if I look at it really quick, 517 to 518. Yeah, it's not that bad. You can handle that. It's just asking you about correlation coefficients and that kind of stuff. Alright? Okay. Let's see now what else that she has on here for us. Curve fitting. All data is not necessarily linear. So we just found the linear regression equation for this. But just like I showed you on this chart, if I go back to stat, over to calculate, there's not just linear regression. There's a bunch of different ones if I keep scrolling down. And the ones that we are going to use the most. Oh, also, don't get confused with this. Number 1, I don't know why there's 2 different options for linear regression. It was all the way up there for number 4 and then again for number 8. I'm not really sure why. I think it does the same thing. But right below it, this says LN regression. That's not linear regression, it's natural log regression. Some people were getting confused and hitting that button on the test, so please don't do that. That's natural log, not linear. The ones that we're going to use the most are exponential, which is option number 0. Logarithmic, which is, that's natural log right there. Where is log? Maybe we just use natural log. So I see LN regression, and then we run out of options. So I think that that's just natural log regression, which is LN, which is number 9. Power regression, which means like x squared, x to the 3rd power, x to the 4th power, all that fun stuff. Quadratic regression, quadratic is x squared. And cubic regression, which is x to the 3rd. So I'm going to stop this video right now, and then we're just going to go back through and talk about what each of these pictures actually look like, and then we should be done for this chapter, okay?